because this is optimization assignment number 2. All right, so let's have a look at this. Are there more? There are more parts to this, right? There's like 4 parts. Is that right?
Yeah, 4 parts.
Okay. Okay, and then I gotta probably go down. There we go. Maximum height, velocity. Gotcha.
So this is a little bit slightly back on the thing that we were talking about earlier.
Mm-hmm.
So you know how technology is growing exponentially, like the power of the processors, the size of them are growing exponentially.
Mm-hmm.
Is the same thing happening with our, I guess, essentially maximum speed that we can travel?
I don't know the answer to that. I don't know the answer to that. I would suspect that.
I'm trying to Google it, but I don't even know.
Yeah, I would think that maybe it's going to be not quite that way. I would think that it's going to go in kind of quantum jumps when new technologies. I mean, right now we're pretty much just still trying to wring as much as we can out of chemical propulsion, which is a pretty inefficient way of doing it. But there could be better. I mean, there are better ways. Physically, we know there are better ways. It's just a matter of making it happen. Okay, so let's have a little look at this then. So if this function is, they give us the height function, here it is, right? S stands for height as a function of time. Find the object's velocity at t equals 4, its maximum height when it occurs, and its velocity when s equals 0. So this is pretty cool because this takes the kinematic stuff that we've done in physics and takes it to kind of the next level, right? Now it becomes sort of a calculus-based physics approach to kinematics, right? So if we know that this is s of t, this is height.
We should do this in physics. Yeah.
Well, I'd like to, but it's not gonna. No, I'm sorry.
Just don't even talk about it. Just start working through it.
Right. That would. I'm sure that would make people feel real at ease. You're throwing out different derivatives.
Just
okay. So what's our velocity function going to be then? How's velocity related to position? Derivative. Right. Okay. So rate of change of position. So v of t. Then this is a polynomial. It's easy to differentiate. What's the first term going to be?
32t plus t4.
Okay, good. So then we want to know what's the velocity of the object at t equals 4. Well, what do I do? Plug in 4. It's just v of 4.
What'd you get for v? What'd you get for the last one?
And that's it. It's 112 evidently if we plug in v equals 4. Okay? Right? No big deal. Okay, what about number 2? Maximum height occurs where? So now we can look at this in terms of calculus. We've got this height function. We're just trying to maximize height. And we can see right away, I mean, this is a quadratic function with a negative value of a, right? So going back to algebra 2, I mean, you know that that's just going to be a parabola that opens downward, right? Okay, so we know we're going to get a maximum, even if we just think about the type of function that describes this. But finding it shouldn't be that big a deal, right? We can just make a table. And while we're at it...
Well, would we even need to make a table? Because if we know that it's an upside down parabola,
yes, we need tables.
We could just set, the derivative equal to 0, find the one value that it's equal to 0, and then that's...
Yeah, you're right. But how much harder was it for us just to do this? Well, what's a of t is just going to be the second derivative.
Okay.
What is it?
Negative 32.
Well, if it's always negative, what's that tell us? It's always concave down, right? So we know right there's our table, right? We don't have to maybe make the table because we know it's going to be a negative second derivative, and we just have to find the 0 of the first derivative, right? So then we would just say that v equals 0 when t equals what? 240 divided by 32, right? Everybody agree? If I set that equal to 0 and solve? Which is what? 7.5?
Yeah.
Okay.
Yeah.
Is it?
Agreed.
Yeah.
Yeah, it is.
Yeah, it's 7.5.
Okay.
Yeah. 30 is
Do we sound unsure?
plus
Between 20 and 6.
24 plus 16.
Okay.
Negative 2.
Mental math.
Okay. Oh, there it is. 7.5. Yeah. So when t is 7.5. So then, what would the maximum height be? How would I know? If we're trying to calculate the maximum value, that would just be the
original
composition. Yeah, plug it into the original, right? That would just be the second row on our table, right? If we made a table. Everybody agree? Okay. The velocity is what when s equals 0? Well, that's just plug in 0 and what?
Yeah.
The velocity. Oh, when s is 0. Sorry.
Yeah.
When the position is 0, right? So how would we know that? Because this is just going to be the type of question where we're just going to plug in for part 4. We just want to evaluate v at something, but when? We got to know the time to plug in there, right?
Mhm.
So we just need to know the time associated with the height being 0.
Okay.
Okay, make sense?
So,
Speed equals 0. Right.
So we're just going to set height equal to 0 and solve to find the time. Does that make sense? In order to find t, we're going to take this function up here, set s of t equal to 0. So we're just going to get negative 16 t squared plus 240t plus 180 equals 0. Well, I think I can probably, no I can't, darn it. I can divide all those by probably 8 though, I think. Yeah. So I can divide everything by negative 8. Seems, yeah, right? Doesn't 8 go into that? Oh, no, it does. 4 I can do, right? 4 I can do. 180.
see, because
Yeah, I can do
plugged
4.
it into Aqueduct,
I can do
and
4.
it gave me like, it was like 400ths off. Once I figured that out.
So if I divide everything by negative 4, I'm going to get a 4t squared minus 60t plus, what's this going to be? 45 or something?
Yeah.
Okay, so now how do I find that? Well, I can either just use the quadratic formula. Do I find magic numbers? So I have numbers that multiply to positive 90 and add to negative 60? Ooh. No, probably not, huh? 90? No. It's not going to. So I am going to have to, so this is one where I'm going to have to, either use the quadratic formula or let's just use technology to do it, right?
It doesn't work for me.
So
Aqueduct didn't do it.
let's try it. Let's try it. So if I pull up my graphing calculator,
It's worse than that.
I'm going to use Polysmalt 2 because I just love the name so much.
What is polys?
Do you guys not know about Polysmalt 2?
If you go to apps and you do alpha P,
Yeah.
it's the PLYSN.
Polysmalt 2. Polysmalt 2 is great. Polysmalt 2 is way better than Aqueduct.
Yeah, why did
did we get Aqueduct?
Mrs. Jones made us get Aqueduct.
Oh, no. I always forced this one on my
Oh, well,
Algebra
this
2
one-
students.
I even have polysmalt too.
Yeah. This is way better. Because look what you can do. So you can do other things too, but really what you want is, number 1, polynomial root finder. So you open this thing up. Look what this does. This is a really cool program. So you can pick the order of the polynomial, right? Which is great. So this is going to be 2. You can even pick, look at the style of the answers you want. You can even pick, you can limit yourself to real solutions. You can take complex solutions in standard form, or you could take complex solutions in polar form.
Can I go take a quick field trip to Mrs. Jones?
No. I'll show her this.
Okay.
So let's just do, how about if we just do real solutions as decimals, right? And I'm just going to take them to 2 decimal places. How much do they want it to? Well, actually, I better take it to more than that.
Yeah, they want it.
We're just going to go float.
Hundreds.
Yeah, this is what Jones did.
Okay, because I don't want to, and here's another important, here's another important lesson, right? Here's another important lesson about this. I'm going to use this value of t in another calculation, right? So we talk about this a lot in physics. So then this is what we'd call in physics a calculator number, right? We don't want to round t because then we're going to accumulate rounding error, right? We want to leave t out to as many places as we can. Ideally, we'd like to even just get an exact answer, which we could get from the quadratic formula, couldn't we? Right, that's going to give us an exact answer. But this will be good enough. If we take this out to like 9 places, that's going to be enough. So then we'll just go next. So I hit this off button right there. And now I put in the coefficients. So that's going to be a 4. 4. How do I go to the next one?
60. Oh, mine's different. Enters.
Enter. It is enter.
Yeah,
Oh, there we go.
Yeah.
4, and then I'm going to do a negative 60. Yeah, and yours might be the old style one where you just put them in as A2, A sub 2, A sub 1, A sub 0. That's fine.
Solve.
Negative.
Oh, that's crazy.
Oh, look at that. I even put plus or minus. I'm going to hit minus.
That gave me,
Enter. 60.
I asked for a decimal.
Enter. Plus. Enter 45. That's kind of slick. Look, it looks just like it's supposed to. Wow, check that out. Okay, so then we're going to hit solve, and it tells me those two values.
Yeah, okay.
Okay? That's weird. That's really weird.
Try multiplying them together.
That there are one of those... Let me think about this for a second. So... Negative, so that's going to be S equals S9. That's a little strange.
Paul Smith has failed you.
What?
I doubt it.
What's strange?
Oh, you know what I did?
You took out
I screwed up. Look, that should have been when I factored out a negative. Yeah. Okay, do you see what I saw there that, you guys you see what I saw that kind of threw me off?
It's not negative.
Okay, and this is another good lesson. When you get answers, you always want to ask yourself about the reasonableness of those answers. Okay, that's not reasonable to me that I'm going to get two positive answers like that, one small and one large. Okay, the reason that's not reasonable is because if I look at my original equation, if you know your kinematics at all, right, this is just going to be D naught, or D equals D naught plus V naught T plus 1/2 AT squared, right? So that implies that my initial position was positive, right? Does that make sense? Which means if I'm starting at a positive value in my trajectory, right? If I look at height versus time, oops. This didn't seem right. If we start at a certain height up here, right, that's positive, then we know that this should look like that, right? So then I should have to go backwards a little bit to find out when it was at 0, right? Because what I essentially did was I shot the projectile off the top of a building, let's say, and it came back down, right? To find when it was at the building, when it was at ground level, then it would have either had to have been before I shot the gun, because from the math god's perspective, the bullet just started on the ground and went through my hollow barrel and up in the air, right? We shot it, it started there, but mathematically, it would have always been in motion, right? And it just happened to get to the top of the building when I pulled the trigger. But it would have had to have started a little bit sooner, right? So before time 0, and then it's going to come down and hit at some time in the future, right? Get the idea? So that didn't seem right, okay? And it wasn't right. I screwed up. This should have been what? Negative. Okay, because if I'm dividing by a negative, that should be negative, which means now if we go into, oops, I don't want to go there, I just want to get my calculator. Where's my calculator? Okay, so then we just need to go in here, we need to go to the coefficients again, try those again. So enter, that should be a minus, right? Now we're good. So if I hit solve, there, that's much better, right? Now I get a small negative one, I want the positive one, right? So let's write that down. This is the one thing, I don't know how to do this. If you figure out a way to do this, store. I think I just figured it out. Store. Oh, that's good.
Where you combine things.
Store coefficients, store roots to list. That's good. Ooh, I like this. Enter store X list equals. We'll just call it. How about if we call it? Where's L1? So we'll just go L1. See, those are my list variables down there. Oh man, I'm liking this. And then we'll quit. Okay, and now let's see if this worked. If I go into second list, oh, I got to get out of here. I think I have to go main, quit the app, and now if I go second list L1. Oh, that's not right.
You had to press enter before you hit quit. Whatever it is.
What do I have to do?
You have to press enter before you quit out of poly, whatever it is. So you just press quit after you said line 1.
Oh.
Because like mine, I had to go like line 3.
Okay, because we got to get this figured out because this is big. This is a new feature. I didn't know you could do this on
I
there.
really knew because mine's super old and it has
You can update it though.
Yeah, it works if you just hit
Yeah.
enter
You
afterwards.
just have to-
Oh, it did work. Oh, that is so cool.
See, I had to go like.
Oh,
line
man.
3.
Yeah.
And
So
then
so there it is. Now if I just go solve
Well, what's the use of that though? 'Cause
Okay.
now you have the two numbers.
store, routes to list. Oops. So you said now I hit enter.
Yeah.
Well, no, and then
Put
you do
line
list
1
one.
L1. So I'm gonna go second list one,
And then hit enter.
and then hit enter.
See, I had to go like list.
List
3.
already exists.
So
I
you
went
just
to
have
like
to go
I just
list
kept
2.
going until I got one. And mine was
Okay.
list 3.
All right. So then I go. L3. Oh, nice.
Now if you just do second and then second mode, it'll just go where it should.
It'll what?
Well, you have to hit it twice.
Yeah.
If I hit second,
Second and then mode,
Yeah, just hit the
and then
quit
second.
Oh, that's
and then
cool.
mode,
and then
it does it again.
quit.
3, 6.
Okay.
And
So
then
now-
if you second and then 3. That'll make you just.
Oh, there it is. Whew, that's good.
Wait, that's,
Okay.
How do you use it though?
Okay.
That's different.
So then,
This is what mine has.
how do I grab that one? Let's see.
See, I don't
So-
know how you grab one.
Whoa, wait, what? I still have the 14.2.
Did you not change yours?
Oh, maybe I'm just, yeah, I see, never mind.
See,
So
don't
if I
understand
do-
how to change
oops.
it.
Okay, so if I want to try something. So if I go L3, and I want to do, I think I want to do comma 2, error. Well, I'd have to look that up, how you get, yeah, I'd have to look in the manual to see how you extract those numbers from the list then. Because there's got to be a way you can ask just for the second argument in the list.
He's looking that up right
Are you?
now.
Okay. This is pretty cool though. This would be really helpful. This is the kind of stuff like you could use on placement tests and standardized tests, these kinds of little tricks that are good. Anything? Days of week. There's a function in there for days of week.
Ah, figured it out.
What is it?
So you just do list, or I guess for you it'd be list 3 and then in parentheses 2.
Oh, okay, in parentheses too.
Yeah.
Gotcha. Nice. So L3,
This is what.
in parentheses 2. There it is. So you want the second argument of that list. That's pretty cool. So there's our time. How about that? Now we got a calculator number. So all we've got to do then is put that calculator number back into the velocity function, right? Right there. Okay, another little trick, in case I haven't showed you guys this.
Oh, the variable.
The variable one, right. So now I could say something like, okay, I'm going to go ahead and store that answer as X. Okay, so if I type X and hit enter, it gives me back that number, right? I can now write any expression I want to in terms of X and evaluate it for that value, right? So in this case, it's not a big deal to just put the X in there, right? But what if I had a more complicated function and I wanted to try repeated values of X, which is another really valuable thing to be able to do. I could just say negative 32X plus 240, hit enter, and look what it does. It gives me back the answer, which you will now notice is the answer. Oh, it is off a little bit.
Yeah, see, it's
By
like,
exactly
it's like
0.04.
4 tens. Yeah, or 400s. That's how far mine's off. Mine is off too.
Maybe you accidentally put 240.04. Or I guess 239.
That's weird.
Oh my god, Wi-Fi.
That's really strange because it shouldn't make.
Because yeah, it's 400 off. That's every one I tried. That's I only missed it by.
And this is actually a Math Excel question.
I can't connect to Wi-Fi or else I tell you.
Can we angrily call Math Excel?
Can we angrily call the ESD so we can get our Wi-Fi working? That'd be great.
At the STEM thing, there was people trying to get.
Huh, that's weird. So I'm wondering if they would have maybe, let's see so did they round this? So if they rounded this a little bit, they would have gotten, like if they rounded this to 2 places, which would have been wrong, it would have been 15.72.
Well, we can just try it.
Let's try it. So
I bet that's what they did.
15.72 store X. Okay, and let's go up and grab that expression again. See how handy that is? Grab that expression and hit enter. That's it. Okay, that's what they did. See, that's dumb. They shouldn't do that. That's a mistake.
Call them up.
That's a mistake because they have just propagated error by doing that. Right? You don't want to round a calculation prior to the last step, because if you do that, you're going to propagate error. Okay. So evidently on this problem, you do have to round it.
That's weird though, because I didn't round mine and I got the same exact.
Okay, well, half the time it's going to work. It just depends if it rounds up or down from, well, not half the time. That's not true.
Yeah.
I mean, not necessarily, but it could work if, like, what if this number had been 15.71000134 or something, right? Then it's close enough to what it's when you round it to 2 decimal places, you're not actually changing the number much, and so it might work, right?
Okay, so mine still says it's off. Like mine, I put in negative 101.44, and it says the correct answer is negative 101.12.
When you round it to 2 places.
Yeah,
Well, that's a pretty crappy problem.
that's what I'm thinking.
I really don't like that very well. So how do we go to the,
Oh, yeah.
Did it work?
Well, no, I had to use the other. I had to use the negative.
Let's just view an example real quick and see what they did. So,
I hope there's a
Oh, I rounded wrong.
oh, okay. So that is going to work, but I still don't like that.
Damn it, now I have to redo it again.
Why is that?
You can expand it, like drag, probably. Nope. Yeah.
There we go.
Physics.
Okay, so then maximum height we got, let's continue. Height of the object at 3.5 seconds is 3.5, gotcha. Find the velocity, first solve. Okay, so we got that. See, rounded the nearest hundredth. They shouldn't have done that. If you're going to go through the hassle of actually doing a square, using the quadratic formula, just use that whole expression because you want the exact answer, right? You do not want to be rounding. Yeah, that's not good.
Well, it
Shame on
says-
them.
Well, they said those not to round it, but when rounded to the nearest 100.
Okay, but that's not. But look, they're rounding an intermediate step. They're rounding the time.
But they're
Right.
not telling us to round necessarily.
But they still.
But they
But
said
but they gave you the wrong answer if you didn't round.
Yeah.
So they kind of are, right?
Yeah.
So that's yeah. Hey, we caught them. That's not good.
Someone commented on my Pandora profile.
Uh oh. Okay, so we good with that? Any other? What about the other ones?
Number 3, I just didn't know what to set as like the parent equation and like which one to use.
Okay, should we look at? Well, we got a little timer. Should we look at number 3?
Like 4 minutes, so sure.
Okay, let's at least see if we can get it set up.
Star wheezes, how are you today, dear friendo?
Okay, you probably want to get off of that while we're in class. I know you just did accomplish something really good.
I did.
And you're
I got
feeling-
the L2, L1.
You're feeling pretty good about things.
What's your Pandora key?
Huh? Why did she tell us, Jonathan? I'm sure it was you.
Wait.
But it was you.
Yeah. La Familia Hughes. Oh, sounds like Jonathan.
You guys.
Oh, what happened there?
Tell you. That's the La Familia Hughes. Okay, whatever. Jesus Christ. Hughes.
Okay, so what about this one? What about this one? So this is really similar to the one we did. It's a little bit easier, but it's similar to the one we did with the boat, right? So a hunter is going to a point along a riverbank. He wants to get to his cabin located 5 miles north and 9 miles west. Okay,
Wow, make sure.
right? So we got the picture. So we got the picture here, right?
Okay, so.
So he's starting here and he wants to get to his cabin. Here's the river. It's not a very good picture. Here's the river. So he's going to have to travel 9 miles down the river and north 5 miles, unless he picks a better path, right? He wants to get there in minimum time. He can travel 5 miles an hour along the river, but only 3 miles per hour on the rocky land. Okay? So then really all this is, if we call, probably which variable should we call x? Probably this one, and the only reason being, if I call this one x and that's 9 minus x, then that's a complicated, right?
Yeah.
We got to use Pythagorean theorem. So let's call that variable x. So that's just 9 minus x, right? That makes the length of the hypotenuse up here, what, square root of x squared plus 25? Everybody agree? Right? Just the hypotenuse. And so then if we're going to write this in terms of a time, we know that v equals d over t, so t equals d over v, right? And so time 1 is just going to be the amount of time it takes to go, well, let's just do the 9 minus x, right? So we're going to have
So which one?
t1 equals this distance along the river divided by 5, right? So that one's weighted by the speed.
Wait,
Plus.
Oh, never mind, no, you're good. You're
Okay.
good.
Make sense? Yeah. Plus this distance, square root of x squared plus 25 over the, divided by the speed, v is just speed, right? Along the land, which is 3, and what's our domain going to be? So this is actually kind of nice. There's no secondary equation needed. What's our domain going to be? X could be what?
1 to 9.
Well, probably 0 to 9, right? 0 to 9, depending on where you leave the river.
And then you just.
Yeah, and so how far upriver should he go in order to reach the cabin? Let's say we got an answer of x equals 5. What would the answer be? 4, yeah, right? Because that distance is represented by 9 minus x. Okay, I gave you, I think there's only 2 on the assignment tonight, is that right? You looked at
I
it?
don't know. I would look at it, yeah.
Okay, got a couple more for tonight.
Is physics still testing?
No, I think we're good to start moving forward a little bit.
Okay.
Yep.
Wait. So we're doing this now?
Yeah, I'll give you more of a chance to test later, but
Oh, yeah?
At all?
Everyone's struggling now, I don't know.
Oh, yeah?
Yeah.
Can you request me?
Yeah.
You're having
Do they really call black dwarfs like extra